All right, so we are going to apply the same concepts that we looked at last module. Now we're going to look at power to a power. So as I did on the first ones on the other two worksheets, we're going to look at expanded form. So remember, anything raised to this fourth power out here means that it's written out that many times. It's multiplied out that many times. So if I wrote this out in expanded form, I'd have 2 squared times 2 squared times 2 squared times 2 squared, right? Out 4 times. And you guys all know from your multiplying part from the last module that I just have to add these up. So I have 2, 4, 6, 8 2's. So that's 2 to the 8th power. So essentially how I'm thinking about this is I have 2 of them written out 4 times. So 2 times 4 is 8. All right, so let's work through here. So we have 3 y's written out 3 times. So 3 of them written out 3 times would be 9. So y to the 9th power. Okay, go ahead and do the other two. Pause the video, do the other two, and then you can unpause the video when you're ready. Okay, so 3 7's written out 2 times. 3 times 2 is 6, so 7 to the 6th power. Oh, my 6 doesn't want to work. There we go. Okay. For number 4 there, we have 4 x's written out 2 times. So 4 times 2 is 8. That's x to the 8th power. All right, let's go ahead and move on to the second section. So if there are ever parentheses around an expression with an outside exponent, we are very simply going to apply whatever is there to everything inside the parentheses. So I'm applying that 2, so I get 2 squared times 5 squared. If there's a number and a variable, they both get applied. So 2 squared is 4, 5 squared is 25, so 4 times 25 would be 100 for my final answer there. If I have 6a squared, so remember coefficients and bases do not have the same rules. So 6 is a coefficient because it does not have an exponent on it, right? So I do what I see. I see 6 to the 2nd power. So 6 to the 2nd power is 6 times 6, not 6 times 2. 6 times 6 is 36. And then I have, so now I apply my exponent rules. A single a written out 2 times, so that's a squared. All right, now I'm going to zoom back out. Go ahead and pause the video, do the other two, and then you can unpause the video when you're ready for me. Okay, so we have 5 to the 3rd power times 4 to the 3rd power. So let's see, what would that be? 5 to the 3rd power is 125. 4 to the 3rd power is 64. And then I need 125 times 64 is 8,000. Okay, for number 4, 3 and 4 are the ones that you'll probably be looking at the most. So I have a coefficient of 3. Do what you see. 3 squared is not 3 times 2, it's 3 times 3, right? 3 times itself, which is 9. A single x written out 2 times would be x squared. Okay, and then let's look down here at the bottom section. So even if it's a fraction that is raised to an outside exponent, it applies to everything on top and everything on bottom. So here we have 2 squared, which you know 2 squared is 4, over 3 squared, which 3 squared is 9. So 4 over 9 is my answer. Down on number 3, we have x to the 3rd power. So a single x written out 3 times would be x to the 3rd power. And then coefficients, do what you see. On the bottom, I see 2 to the 3rd power. That's 2 times 2 times 2, which is 8. So x to the 3rd over 8. So go ahead and pause the video, do the other two, and then you can unpause when you're ready for me. All right, so on number 2, 4 to the 3rd power is 4 times 4 times 4, that's 64. And 3 to the 3rd power, that's 3 times 3 times 3, that's 27. And just a hint to you, always try inside these parentheses to simplify first. If you can simplify first here and then apply your outside exponent, that's going to make your life a lot easier. If you can't simplify here, you're not going to be able to simplify on your final answer. So that's why it's nice to do it first. And then on number 4, I have a single a written out 4 times, so that's a to the 4th. and a single b written out 4 times, that's b to the fourth.